Spec-driven design has a problem because when you are working with spec-driven design, the AI needs to understand the complete scope of the specs. You could say like, oh, but we're only working on this feature, but how does that relate to all the other features? A normal human would look on the complete spec and understand the specification in relation to the complete scope. But that's not possible for AI. You know, the context window, and it cannot hold the whole complete spec. The context window is too small. And I mean, in reality, it's not even the context windows which is the problem. I would say that many people are talking, of course, with the context window, it's this and this, and of course, context windows is important, but something which is even more important, but much harder to measure, is cognitive load. And that's something I always strive to reduce on my AI, because as soon as AI need to do a task, you need to like see how much cognitive load is needed to complete the task, because AI have a limited cognitive load. If you, for example, ask it to look on the specifications and see that what you have written is not colliding with what you have implemented before, then the AI needs to take it all in. But what instead is better is to have tests, because test is just one line, run all the tests, and it automatically sees what is working and what's not working. So I would say that trying to have the test well written, well structured, and that to be the documentation instead of the spec-driven design. Of course, I do spec-driven in parts. So when I do something, I have a lot of task list and so on. I do that, but not think that you can hand over a complete specification PRD, which is like 20 pages, and get something useful out of it. AI cannot handle that cognitive load. Classic TDD, a short recap. When you do that normally, you have three phases. You have writing the test, and which will fail, of course, since the code is not implemented yet. Then you write code which make the test pass. Then you do some refactoring, and then you test that the test pass again. And then you loop back, write some tests for the new feature that you're implementing, then adding the code needed to make the test pass, and then refactoring, and then running the test again. So it's like an iterative process. I tried that with AI. It takes forever and it's really slow. And that's not really how AI works. So you need to adapt this to work with AI. The AI loop is different. So what I do is I have explore, plan, implement, test, and fix. And this is sounds like, okay, but how is that AI TDD? It's because the tests are in the forefront. They are what drives the scope, and it's like an expanding safety net of your whole application. And this is something which is very important, because you have a very low cognitive load way of AI. Am I on the right spot? Am I doing something which is actually useful moving forward? And if you would go off right now and just trade that, you will run into some problems. Because if you do, for example, game development, which I mostly talk about on this channel, even though I actually don't do game development, but the coding behind it, I use Unity a lot for B2B application. So with that said, the game development is a very special case, because we have this world, this concept, this 3D space. LLMs are not strong in that area. That's the fact. The game dev special case is that we need to reduce the cognitive load of the AI to understand the test, because AI try to cheat the test. I don't know how many times I've seen an AI trying to, instead of actually implementing the test, realize like, oh, I don't really know how to do it, so I probably should do a workaround. So I write the parameter to true, and now the test pass. Wonderful, especially if you have had auto compact, then it will even more do this because it lost the context of why am I actually doing this. And this is a real problem, I would say. So instead of having AI cheat test, do a simulation API that move and move the avatar around. So, for example, if you would have a character, you would move it around using the human inputs. You would never use anything like the like kill enemy. Instead, it's like moving joystick forward, pressing the A button, pressing the B button, but you have recipes. So instead of actually driving the avatar by these exact button commands, you let the AI just get the API to access things like move to this position. And under the hood, the system moves the joystick so that the player moves in that direction and then stop when it comes to that position, for example, if you have moved to this position as a recipe. But you can also have fire at that enemy. Then you would rotate the joystick in that direction so that the player is facing that direction to the enemy, pressing the B button. But in reality, what AI sees is fire at enemy and then just importing the enemy game object, and then automatically the simulation takes care of this. And this is reducing cognitive load that I talked about. And this is the way how you make AI write its own tests and iterate on it in real, so to say. So with this said, use AI TDD to improve your AI's cognitive load and be able to validate what it's actually doing. Because the validation loop is what makes you less important in the loop. And yeah, I hope you had some useful insights and learned something. And I'm really interested in knowing how you are doing the test. And are you doing test-driven development? And if so, how is that working? Really looking forward to hear something, and have a great day. Bye.